Dear all, today we are going to discuss about the Hund's rule to predict the ground state term, that is the lowest energy level for an electronic system. So for example, if you see the P2 electronic system, it is having three energy levels, that is three triplet P, singlet D and singlet S. Okay, from these three, which will be the lowest energy level and which will be the highest energy level will be the question here. So to write the lowest energy level, uh, Hunds has proposed the rules, three rules. Okay, so from these three, the first rule states that of the term which is having the highest spin multiplicity will be the lowest energy level. For example, if we taking P2 electronic system, it is having three terms. So we comparing two terms, two energy level, that is triplet P and singlet D. So from these two, which is having the highest spin multiplicity will be the lowest energy level. And then the next one is the highest energy level. And then the next rule, the terms which is having the same spin multiplicity, then we considering the highest L value will be the lowest energy level. So if we taking the D2 electronic system, for D2 electronic system, 5 energy levels are there. So we comparing 3 energy levels which is having the same spin multiplicity, triplet P, triplet F. From these two, the energy level which is having the large L value, highest L value will be the lowest energy level, and the next one will be the next higher energy level. And then the third rule states that of the terms which is having same spin multiplicity and same L values, then we'll consider the J values, total angular momentum values. In that, the lowest J value will be the lowest energy level for less than half filled configuration, that is less than D5, that is D1 to D5 configurations. And the highest J value will be the lowest energy level for greater than D5, that is greater than half filled configuration, that is D6 to D10. For example, if we see the 3F energy level, it is having three states, 3F4, 3F3, 3F2. In these cases, the lowest energy level for D2 electronic system, that is less than half filled configuration. From these three, the lowest J value will be the lowest energy level, that is 3F2 will be the lowest energy level. If for D8 electronic configuration, so for D8 electronic system, it is greater than half filled configuration, right? So the highest J value, the term, the energy level which is having the highest J value will be the lowest energy level for greater than half filled configuration. So by considering these three rules, we will predict the ground state term for the some example complex, that is hexaqua nickel complex. So the electronic configuration of this metal ion is 3d8 to 4s2, that is argon 3d8 4s2. So nickel is in +2 oxidation state. Then we considering the electronic system as D8 and high spin complex, weak field complex, right? So D8 electrons will be filled like this. Two unpaired electrons are there. So if we calculate the L value, +2, +1, 0, -1, -2. In +2 shell, 2 electrons are there, +1, 2 electrons are there. So total +6 and -1, -2, -3. So L value is 3. So the term will be F. So L value 0, 1, 2, 3, 4. The terms will be, as we know, S, P, D, F, G, H like this, right? So when the L value is 3, the term symbol, the acquired term symbol will be F, right? And N is unpaired electrons. Number of unpaired electrons are 2 here, right? So the spin multiplicity N plus 1 will be 3. And S value, S is N by 2, right? So 2 unpaired electrons are there, 2 by 2 is 1. And we left with to calculate the J values. So J values will lies like L plus S to L minus S. So L is 3 and S is 1. that is 3 plus 1 to 3 minus 1. So if we calculate the j values will be 3. 3 plus 1 to 3 minus 1, that is 4, 3, 2. Right? So, and it is D8 electronic system, that is greater than off-field configuration. So, the maximum J value will be considered as the ground state term, that is 3F4 will be the ground state for this complex, that is nickel system. Okay. So this is the process to write the ground state term by using the Hund's rule.